Hey guys, it's Mr. Jank here. Today I want to go over two questions with you. The first one is number 2, and the second one is number 3. Let's do it. Okay, the second question said, calculate the pH of a solution that initially contains 0.2 amps and concentration of Cn minus, and Kb value of the Cn is 2.0 times 10 to the negative 5. And as we can see, Cn don't have hydrogen to donate, and also they give us the Kb value on the other hand, which means Cn is actually a base. Then we can write out our formula, write out our equations, and we have learned that in the conjugate base acid and base units. Okay, Cn is going to receive one hydrogen from the water, and because it's a base, it's an acid, so water is going to donate one hydrogen, and now it's become HCN plus OH minus. Right now, we have noticed that Cn actually is weak base, and we can find that in our periodic table, and HCN is actually a weak base. HCN is actually a weak base, and we can notice that. So we can write down I try to say it's like this double arrow thing, and we can write down our rice table. So write down our rice table. I see, and ratio is always 1:1. But if you don't believe that, just check it. It's Cn and 1 Cn, and hydrogen have 2, and this one have 2 hydrogen, and or have 1 oxygen, Now it's 1:1, and all 1. And every time we just in the rice table, in this type of question, in this type of titration question, we ignore the water, because water is act as a pure liquid in here. Anything we have a pure liquid or maybe a solid, we have to ignore that in our rice table, or maybe in our calculate the KEQ value, and yeah. Okay, so in our rice table now, it's talking about initially have 0.2 of Cn, should have initially 0.2 of Cn m, and the other stuff he did not give us, so we just assume it becomes 0. Now we don't know anything other than that, so we just put the x, because 1:1 ratio, put a plus x, and this one is minus x, and now we can get the answer is like 0.2 minus x. Now, so one thing I try to say is if the question don't give us hydrogen, pH value, or maybe concentration of H3O, or maybe pHO, or maybe the concentration of OH minus, then we must do the assumption. So if you're a good guy good at math, you can use the quadratic formula as Miss Hill said, and that's not matter. But I'm not good at that. So let's make an assumption. So use 0.2 minus x and equal 0.2. That's with the concentration. Now what can we do next? So it also want us to calculate the pH. Then we have the Kb is also giving us. Then we must be calculate the Kb and also have an OH here. Then Kb formula is also this product over reactant, but without the pure liquid. Okay, so HCN concentration and also OH minus and Cn minus, then will become x squared, because x times x is x squared divided by, I'll make assumption 0.2, and Kb value is already giving us is 2.0 times 10 to negative 5. Then we put in here. Now we can calculate the x value. When we calculate the x value out, I can show you it's actually, I can double put in my calculator, and times, and we got 2 times 10 to the negative 3, and it's also 2 times 10 to the negative 3. Yes, so OH minus in here is actually, if you notice that OH minus have the same concentration value with the x, then we must if we want to calculate the pH value, then we need to use the Kw value, the Kw formula, because OH minus times H3O, the concentration 2 times together, is equal to the Kw value. Kw value, we don't know that. If we don't know that, we just check the periodic table. 1.0 times 10 to negative 14, then we can calculate the Kw value. Now, we use the Kw value to divide by the OH concentration value, and we get H3O, the concentration of H3O, which is 5 times 10 to negative 12. Now, we get the H3O value, then we can calculate the pH value. That is so easy. And pH is equal negative 0 to H3O plus concentration. Now, we just putting 5 times 10 to negative 12 into the H3O there, and we can calculate the pH value, which is 11.30. In other words, we can also use another way to calculate the pH value. If you have more than one formula, and if you calculate the OH in here, we can indirectly to calculate the POH first. We can calculate the POH first. Sorry, number 4. Okay, we can calculate the POH first by putting the OH into here, and we know pH plus POH equal 14. So use 14 to minus to subtract the 2.698, and we get the number which is directly 11.32302. Then now we can compare our answer. It's 1130, which is they are same. Oh, then we get the first question. So as you can see, there's two methods that we can solve this type of question. Lastly, if you just try to make sure your answer is correct, I always check my answer. So how to do so is use 0.20 to do this number to subtract x, is what we calculate now. Is 2 times 10 to negative 3, and we're putting in here, and I think the answer is 0.18198, which is if you consider the sixth phase, which is similar like 0.2. Now the two consistent answers tell us our procedure is correct.